Hello, good evening. Hello, everybody. Thank you for coming for today's lecture. I want to welcome here Summer Islam from London, from the studio or collective Material Cultures. I'm really happy to have you here. I will do like short introduction and then we can start the lecture. Summer Islam, she studied architecture in Turkey and later in London at the AA. And after her studies, she started to work as an architect in several offices in London. And in 2019, she founded, together with her colleagues, a collective, Material Cultures, together with George Massoud and Paloma Gormley. So since then they are working together and they are interested in topics of materiality and post-carbon strategies for our building industry and our post-carbon future, let's say. So they are interested in architecture design, but also in teaching and doing their own research. So you actually teach at the ETH University in Zurich last year, and but also in London on St. Martin's University and Berkeley. No,
it's close enough.
No, UCL. Sorry for this. Yeah, you also published quite a nice book, which I want to recommend you to have, which called Material Reform. And now I'm already giving the word to Summer, and enjoy the lecture. Thank you.
Oh, thank you so much. And thank you everyone for having me. It's a real privilege to be here. Yes, I'm going to talk a bit about our work broadly as an organization and then specifically through a series of projects. So, Material Cultures, we're a not-for-profit organization, and we do research and design at the intersection of natural materials and low-embodied carbon and construction technology. And in our work, we advocate for material reform through design and research and education. We also increasingly argue for the reintegration of architecture and agriculture because we see our buildings as irrevocably linked to landscapes of extraction. So when we design buildings, we do this with bio-based materials as much as possible. And we also think in every building project about making the construction systems efficient. So thinking about contemporary modes of fabrication like prefab and offsite as well as on-site prefabrication systems. Wherever we can, we also promote the reuse of existing buildings and their refurbishment. And think in those refurbishment projects also about how you integrate bio-based materials and natural materials. And then a large strand of our work as an organization began as research. So we look at strategic research into how the ideas we embody in our design work could extend across a whole region and scale. And broadly speaking, we think about how we can integrate circular economy practices and regenerative land management in a kind of bioregional or an eco-regional system. And our work works through all these different scales. So we work at the one-to-one, but also, as much as possible, we are interested in the impact of the work growing. And so work across large-scale housing developments, as well as kind of hands-on fabrication, prototyping for design projects, but also working with our students to think about kind of experimental and innovative building typologies with natural materials. And we teach, so we do lots of education work in architectural schools, but also we have a platform now called Make that we set up a couple of years ago, where we run building skills workshops, broadening the understanding and access to natural materials and construction, in construction and on construction projects. And as has already been said, we publish a lot of our work online and open source, but we've also recently published a book called Material Reform, which is a collection of essays looking at the destructive ecologies which are fostered by the construction industry. And increasingly, the way that we have come to conceptualize the work is to think about it in the context of the landscape, not just within which the project sits, but also from which the materials we work with are drawn. So I'm going to talk through a series of landscapes to articulate the project, and start to maybe, I guess, posit the connection that could be had between buildings and the landscapes they sit in. So in farmland, we work a lot with straw. And straw, which is a stem of cereal crops, is very versatile. If you leave it in the field, it can be used for bedding, or it's often burnt. And then the carbon dioxide, which is sequestered in the plant while it's growing, is released back to the atmosphere. But by contrast, if you take that plant matter and integrate it into the building and use it as a substitute for other materials, you could think of it very simply as a carbon battery or a carbon store. So if you apply this logic to a house, in our research we found that if you substitute readily available plant-based building materials in a standard developer house like this one, so buildings like this are built across the UK landscape, you could turn each individual house from a net producer of greenhouse gases to a kind of carbon negative unit of storage. And we've also looked in this work at the amount of land that you need to grow the amount of plants that you need to do this work. And what we found was actually the land use is really negligible. It's a kind of fraction of what's already going on there. So there's lots of farming happening in the region more broadly, and the amount that you need to produce the materials to house the people who are looking for new housing is really, really small. But the amount of economic gain for that whole region of the UK was massive. It was extraordinary. And it's one of those things where you start to understand that this transition to a different material supply chain and a kind of bio-based way of building is in lots of ways a no-brainer, and we're kind of working at cultural barriers rather than technical ones. Underlying this kind of story of agricultural production is also one about how oil-dependent industrial agriculture has really desertified our rural landscapes. It's poisoned our soils and waterways and destroyed natural habitats. And you can see this in the biodiversity loss, which is associated with extraction. And surprisingly, most of this biodiversity loss is actually associated with farming. So today we're dependent on a handful of cultivars in our kind of industrial farming landscapes and in our food systems, which makes them very vulnerable to pests and diseases and also climate change. So if architecture is going to address not just the climate crisis, but also the biodiversity crisis, if we're going to move towards bio-based construction, we also need to accompany this with a move towards a different farming system, which would essentially be regenerative agriculture. Systems like the one that you see on the screen. And so our work has taken us to landscape regeneration now as a starting point for the design of a building. We've been learning from farms, learning from farms like this one in Suffolk, which is called Wakelands. And in this farm system, which you see, they grow crops in narrow alleyways, which are the kind of width of a combine harvester. Each of the verges is a different crop and a different plant. So there's a lot of like diversity in the system, which gives you a kind of cultivation species of grains, and it diversifies and brings resilience really to the farming system as a whole. In parallel, if you think about the kind of industrialization of farming and look at the industrialization of housing, you can see a similar story with the impact of oil on architecture and the loss of vernacular practices that were originally very inherently low carbon and low impact and bioregional. We used to build in this way where it was kind of a gathering up of the materials in the landscape to make a house, and that was substituted by very energy-heavy global supply chains. Contemporary construction materials like steel and reinforced concrete and plastic, they align with a patriarchal and masculinist idea of modernism. They are hard, they are immutable, they're very easy to quantify, and they have the illusion of not needing any care. And maybe, on the other hand, the reason that natural materials have been denigrated is that they align with the feminine, with the soft and the mutable, and they are inviting of careful maintenance and repair. Natural materials perform in ways that are attuned to human occupation. They have an inherent richness, they breathe, they contain compounds that are antifungal or antimicrobial. And the history of vernacular architecture is a history of thousands of years of technological development, of research and testing. of regionally and climatically specific adaptation of individual buildings and material systems, but also of a kind of reciprocal approach to resources. And we've lost a lot of this material technology already, and the knowledge that remains is predominantly haptic and difficult to inscribe and held by just a handful of people. So rebuilding a relationship to repair requires human investment and a different set of relationships to place and territory in the formation of new cultures. At our project at the Wolves Lane Community Centre in London, we've been working on 2 new buildings for the southern portion of the site, so providing space for learning, working, gathering, and distributing food. On this project, we developed a simple system, which is a lightweight timber frame with a straw infill. We've been building with straw bales, taken directly from the fields on the edge of the city. The buildings are very roughly rendered with lime, which is pigmented red, and roofed with simple, lightweight agricultural steel, which slips down the elevations to create a hat. The bales make very deep reveals, because they're very thick. So we have our glazing line, which alternates between the inside and the outside of the external wall, which makes places to sit within and without the building. And the buildings are designed to make a series of courtyards with kind of public-facing and private-facing external space as you move through the site. Our contractor, Work Limited, took our 3D model and built a full kind of digital twin in BIM. Right down to the fixings and the plumbing junctions, they modeled everything, which allowed them to build and order with absolute precision, which is something we found kind of pleasingly transgressive, the idea that you might put straw bales and BIM together in one space. The buildings were designed to be a tool for the learning and communication of the value of plant-based materials to the community. And the project is rooted in principles of social justice, so making spaces to practice, grow, and learn for those who have been historically marginalized in London. Places like Wolves Lane are increasingly important as places from which to build community, knowledge, and enterprise. And through the project, we developed a participatory construction framework, which was apprenticeships, but also skills courses and volunteer sessions. So the construction of the buildings has seen teams of different site users and volunteers exchanging knowledge and learning how to build together. Direct contact with and understanding of materials and their properties and what they feel like is kind of at the center of how we approach design. On this small dairy farm in Cambridgeshire, our client Steve Barron established Margent Farm. And on the site, they looked at growing hemp for use in experimental biocomposite products, which could kind of substitute plastics, basically. And the same client commissioned this house called Flat House, which is a hemp-based flat pack demonstrator project which shows the versatility of hemp. The building takes the form of the existing steel frame barn and retains part of the structure to support a kind of glazed hothouse and a climbing frame for the plants. So we established a new, sorry, I'm recovering from a cough. We established a new crop rotation. So the hemp was sown in the fields which were previously wheat. It's actually a very good rotation between wheat and hemp. They kind of feed off each other. And the very long roots of the hemp plant, they send carbon deep into the soil, but they also kind of rebuild the soil structure. So it's a very good break crop. And then what you get when you harvest hemp is this amazing stem of the plant. You get 2 things. You get the seed as a kind of primary thing, and then the kind of lesser used products of the fiber around the stem, and then the stalk, which is the sheaf. We had to then send the harvested hemp from Cambridgeshire, where our site was, up to Yorkshire to find the set of machinery that we needed to do this process, but it's essentially breaking the stem of the plant apart. And then it was sent to Buckinghamshire, where it was combined with lime and cast into these panels. We designed the system with our collaborators Will Stanix and Oscar Cooper, and then we built the building with Henry Stringer very, very quickly, in about 2 days. The cladding for the project was developed with Margent Farm, and then we made this new material product, which was kind of one of the drivers for the for Margent Farm. It was combining the hemp fiber with a sugar-based resin to make a corrugated rain screen. And then internally, we work to kind of shift scales and also, where possible, really just leave the hempcrete exposed so that it was something that was visible. I guess part of the way that we think about materials in design is that when you can see them in the interior finishes, there's both you have an understanding of how the building is put together, but you also have the ability to adapt and maintain and kind of intervene with the building throughout its lifetime. And then the kind of final kind of farmland project is this one in Lewes, which is a development on an ex-industrial site in Sussex. We've been working with a developer called Human Nature, and they're kind of rebuilding this big swathe of land across the edge of the river and making a new 700-home development. And our plot are these 4 blocks that you see here, making 70 homes, and the intention is to make a 4 or 5-story timber frame and hempcrete building project there as well. Designed in a kind of very dense urban configuration and arranged around shared courtyards and kind of communal gardens. So a kind of series of very simple typologies that make these varied building units, really thinking about different ways of sharing public space. So from the communal garden to the deck to the terrace. And we hope when we get to building this project on site, it's just got planning, that we'll be able to start demonstrating what's possible when you use these material systems and apply them at scale. Because we think that the larger scale projects are a kind of an opportunity to rebuild and re-knit the material supply chains we've lost, where we used to have more material processing and more industry distributed across our countryside. But we've lost that, where it's become centralized and monopolized across at least the landscape of the UK. And we hope these projects are really an attempt to make a new language which is descriptive of the bioregion, that really talks in the buildings about where the buildings are and the kind of materially descriptive of the landscape around them. When we build our structures, it's very hard for us to use anything other than timber. It makes lots of sense. And so when we start working with timber, we then look to the woodlands in which our trees are grown. We think woodlands are a critical habitat for biodiversity and ecosystem restoration. But they're also intertwined in the UK with the history of common land and the ones that we lost access to. We used to be able to source multiple material streams from a forest, generating lots of different income. But today, the forests of the UK are mostly privately owned. So you can't really walk through a lot of them, you have limited access to them, we have no control about what's grown in them. Converting an agricultural land to woodland can also be seen as the beginning of offshoring deforestation. So plantation development in one place might lead to deforestation somewhere else. So when we start thinking about planting new trees, we also need to think about the impact and the tensions of the relationship between the land uses and how we build. So our sort of starting question when we begin looking at forest is the critical role that timber is going to play in decarbonizing the global industries. How we meet that demand is really critical. And we think today it's going to be met by forests like this, by engineered timber products formed from softwoods in plantation woodlands. Monoculture plantations really deplete the soils beneath them. They have very limited biodiversity in their understory, and they have almost no resilience in the face of climate change. So our research has been speculating really on what would our woodlands, our landscapes look like if the way we planned our forests and our forestry practices was designed around soil health rather than around the needs of industry. And then consequently, what kind of buildings might emerge from that? What material language would we have instead? So we did a piece of work at the Design Museum at the Future Observatory, where we were their fellows, investigating the opportunities really for resilient treescapes and regenerative land use management practices to repair the landscapes we have, which are degraded. So we sort of looked at a future land use model, a mosaic alternative to monoculture landscapes. So where you might weave arable farmland with short rotation forestry, you might have quick growing coppice, hazel, and willow and shelter belts of broadleaf tree species. And our research has explored how you would work with those materials and products that might be drawn from a much more diverse type of landscape. We publish all this research online. It's on our website. And we worked with our students to collaborate on the design of building systems, which are prototypical and experimental, but work with materials that are grown in the woodlands we have today, but also speculating on timber that might be grown in our woodlands in the future. So this prototype, for example, is made with eucalyptus, which is very rarely used for construction, but it's grown across different parts of Europe for paper and pulp production. It's incredibly flammable, unfortunately. Alternative treescape models are kind of inevitably going to be lower yield. And in a sustainable future, the construction industry would have to adapt to these different landscape systems. So while we look to grow more diverse treescapes, there's a kind of parallel project in thinking about the skills we need to manage those forests and those woodlands and to think about how we extract timber from those systems. So broadly speaking, although we think the principles of working with bio-based materials are good, it's buildings like this which we think we need to question, because the evidence suggests that as the supply and demand globally for engineered timber grows, global biodiversity declines at a proportionate rate. We have very scarce forestry resources, and the ecosystems they support are incredibly valuable. So we need to be using those resources to make lean and lightweight timber buildings. So a very early project of ours, which centered timber supply chains in its design thinking, was called Plank House. Plank House is a self-built 3-story home. It was built in London, and it was designed by Practice Architecture, kind of one of our earlier previous studios, in very close collaboration with the client. It's a self-built project, so in many ways it's still ongoing. It's a story of homeowner agency, of continued care and maintenance and renewal. It's a monolithic 3-story timber and hempcrete building, cast in situ. And it has in it a textiles workshop and 2 apartments and a raised external courtyard. It's a very flexible building, so you can occupy it in a series of different ways. And we cast the hempcrete in situ, so you get very beautiful lines from the board shuttering when you do these lifts, like when you cast fair-faced concrete the traditional way, but much warmer and softer. And the design approach was intended to use carbon sequestering materials in ways which kind of was complemented by simple and very robust detailing. So all the joints are kind of fair-faced, side-fixed connections with the timber. And the whole building, the frame, the floors, the skirting boards, they were all made using exactly the same section of wood. Quite substantial, chunky planks of wood, all sourced from one sawmill about 100 miles away from the site. And the timber section was actually made bigger than it needed to be for the structure to allow for charring in the case of fire. So we didn't have to use any chemicals to treat the wood. And because it was so large, it also enabled us to have a very unique timber structure, so a kind of balloon frame, which had a 1.2 meter column spacing, and the floorboard spanned something crazy like, it's a meter. It's much bigger than what you'd normally have in a Victorian terraced house. And the primary materials then, because of their size and the way that they're detailed, perform multiple functions at the same time. So because the floorboards are so thick, they're structural, but they're also acoustic. They're the fire lining. So we didn't actually have any ceiling, so you can kind of see the floorboards below, and it eliminates the need for any additional materials for the soffit. And this building was really about celebrating the palette from which it was made, so it's kind of rich in character. And that the primary materials are close at hand also means that they can be adapted and maintained and modified quite easily. But also at the same time that they're put together so simply means it's very simple to take apart. So in the UK, the way that material supply chains are distributed is relatively uneven. Around London, there are quite a lot of skilled sawmills, but further north, when you get towards Scotland, particularly actually on the Isle of Bute, where we've been working, the conditions for milling and sourcing timber are very different. Bute is basically a farming landscape. It was once an entirely forested island, and it has a very rare temperate ecosystem, like a temperate rainforest, actually. And there's a little bit of it left on the tip of the island that you can see there on the map. So it's basically a fully industrial farming landscape now. And our site is this very beautiful stone farmhouse, which has been left derelict for decades. It's a kind of U-shaped farm building, and the idea is that it's sheltered on the courtyard side from the very extreme onshore winds. When we started the project, it had a timber roof, and it was completely destroyed. It was very rotten because they had lost the slates a long time ago. So we had to take it off as its first act, really, was to remove that wood and enable the building to dry out so that we could then start to work with the stone walls again. We had these very wet walls, and the intention was ultimately to lime them, but you kind of have to wait for them to breathe out some of that moisture before you can seal it in with a kind of new hull or a lime render. The plan of the building is very simple. It's this kind of courtyard shape, and the idea was to make two dwellings that were adjacent but independent of each other. And then some of the stone roofs, so the stone walls were left without roofs to make these kind of courtyard gardens which were sheltered from the onshore winds. The new landscaping, which was designed by J&L Gibbons, was intended to be a kind of restructuring of the temperate rainforest which you find on the north of the island, coastal meadows, and native tree species. And at the courtyard side, we have this sort of oversized slate making a porch, which is supported by timber columns. And then internally, we sort of lifted the gable on one side to make a kitchen and living room, which had a bit more generous head height and some kind of top light. And where we can in the project, we're really working with the existing stone walls, which has been a learning and a process for all of us, because there's so much skill and knowledge in masonry. We have a really excellent building surveyor called Kinley Laidlaw. And he's got a kind of innate understanding and lots of experience of working with stone, to the point that he knew to go to the nearby beaches to find the shells which would have been used in making the original mortars in the building, and was able to match exactly which beach the shells had come from in the making of the first lime to make the building. And then we were able to replicate that process, not with these shells, but with other ones that were sourced more sustainably. But he also thinks about the work of the mason on site, which was a kind of revelation to us and sounds so obvious once it's put to you. But he's designed the work in the masonry as you move around the building so that it's not repetitive or boring to do, because it's very physically demanding being a stonemason. So he mixes up the tasks that the masons do so that they're not doing all the dressing at once, but they move between dressing and cutting and back again. Our roofer, Hector Whitelaw, was very experienced and took all the slates off the roof and then put them back on again, resizing them and working with the original slates. And where we're introducing new materials, we're working with a palette of timber and wood fiber insulation, and wood wall boards, and clay plasters. I guess the story maybe of this project is that the island of Bute is host to an aristocratic estate. And like many of the private woodlands across the UK, the estate of the Marquis of Bute is standing not as a native ecosystem, but really a story of kind of the colonial history of the UK, in which special tree species from all over the world have been brought and replanted and hosted in the woodland. And working with the estate managers on the island, and the one tiny sawmill that's there, we really tried to resist the pull to import wood from the mainland, from the much further away forests, and to use the plantation woodland which was there and the wood in the estate in the design of the new roof structure. And Bute Sawmills is incredibly small. This is the entire team, the management team, and they have no in-house structural grading facility, so they weren't equipped to tell us exactly which wood would perform structurally in which way. So our own structural engineer went and trained to do the visual grading that you would ordinarily have maybe as a service in some of the larger scale sawmills. And on a small island like Bute, which has massively depleted in its economy, supporting these active but growing industries is a really important way of building more sustainable material supply chains. But it's very complex. It requires thinking very differently about the role of the architects. And so without support from policy, it's ultimately a much more expensive way of building. What we've learned in these projects is kind of a way of mediating between different industries that are often quite disconnected from each other. This project is a much smaller scale, building in a forest in Yorkshire called Dalby Forest, where we worked on the design of an outdoor classroom education space for Dalby on a project which was funded by the Forestry Commission. The idea was to really use the construction process as a way of learning for us and also for our students in a Masters of Architecture program where we teach. And we were looking really at how you use the wood which comes from the forest we have today. So in the UK, that means quite short sections of timber because our forests don't grow as tall as they do in mainland Europe. And also thinking about locally grown species of tree. We worked with 30 students on this building, so it was prefabricated by a very large team of students. And it worked specifically with timber which is affected by disease, so ash and larch. They're trees which mostly are affected by what you could describe really as global pandemics exacerbated by climate change. The two diseases which they are affected by proliferate in warmer climates. So we worked with the ash and the larch, you can see them in green and orange, to look at how you mix timber in a building so that you work with shorter sections but combine them to make much more complex structures. And the ash sits underneath the protected roof and then the larch protrudes from the envelope. And then externally we clad the building in thermally modified timber, so it's been kind of lightly baked, makes it dark brown, very chocolatey. And then internally wood fiber insulation and a wood wool lining board. And this palette of materials is not really local to us. So the timber frame is definitely one we could source locally. But wood fiber insulation is made in Central Europe. We don't have a factory in the UK. But we could. So really we think of these projects as kind of galvanizing and building demand and talking about why it's important really to have that fabrication closer to home. The whole building was fabricated in 7 weeks, prefabricated in relatively small but well-equipped workshops in King's Cross. And then it was taken up to Yorkshire and it was dry fit in the workshops of our contractor. Turned out it was actually really big. We didn't quite anticipate how tall it was going to be. Ready to be installed while we waited for planning permission, which we finally got, and it's finally gone up last month. So this is inside where you can see the kind of thermally modified timber and the wood wool. And then this is on the outside, the project. Now it's complete. And the idea is that the building will be a site for forest classrooms and education programs, but also a place or a kind of tool for talking about the future of our woodlands and how we respond to climate change with them. I guess all these different timber projects have established for us now a kind of set of timber design principles. I mean, they're quite specific to the UK, but maybe they apply to other places. We work with locally sourced timber as much as we can. And for us, that means if you specify them at C16, so the lower structural grade, you can be relatively sure that it's coming from the UK. As soon as you demand a stronger timber, a higher structural grade, it's probably going to come from the mainland, from Europe, because we don't have that many trees we grow that are of that structural capacity. If we mix the specification with a number of different tree species, we can start to pressure the supply to be from more diverse types of woodland. We also try to minimize how much timber we use as much as we can. And we try to avoid boards and laminated products which have chemical glues and coatings. This is more difficult to do, but they do end up downstream in our waterways. Designing for reuse means using very simple fixings, and where possible, making those fixings out of timber to extend the lifespan of the building. We see our built projects as opportunities to kind of build new supply chains and processing infrastructure, expanding really the understanding of our role and responsibility as architects who work with materials which are inextricably linked to these landscapes of extraction. And the last landscape we started looking at is the wetland. It's kind of a landscape of potential, and it's a very hopeful place in lots of ways. So swamps, marshes, fens and wetlands, they were historically identified as kind of areas of mystery and threat. They were wastelands and they had no inherent benefits to human populations. They're incredible places. They are important migratory zones for birds, and they're carbon sinks, and they're buffers against flooding. But we used to think of them as untamed nature, which needed to be transformed into villages and productive farming land. if you go back this one slide. So here is a historic map of the Fens in eastern England, which is a kind of diverse and wet and soggy place, full of its own kind of biodiversity. And this is the same landscape once it had been drained and had all these drainage and irrigation channels cut into it. So civilizing a swamp essentially means to drain it and to remove the water. A common misconception, if you go back to the kind of the beginning of human settlement, is that we started settling in like dry land that we irrigated, but actually the first human settlements were in wetlands, and they didn't have very well documented written records. Everything biodegraded and kind of decayed, and their cultures were largely oral. But they were very sensible places to settle. They had an abundance of food, of birds, of fish, and they were adaptable places. They were also resistant critically to centralization and control, so there wasn't a single dominant resource which could be monopolized or controlled from the center. So they had like common property in wetlands. Everyone had access to all the plants and to all the animals. You know, this is the kind of context in which we started looking at the wetlands. And we began working on a project for an organization called Bauhaus Earth in Germany, in Brandenburg, where there is a wetland which was also drained, like there are many wetlands across Europe, in the 19th century. And it was intended really to access the peat soils, which is very black when you look at it, which is very fertile and a kind of great grounding for growing crops. But in order to protect the biodiversity of these landscapes and the carbon that's stored within the peat, lots of different projects actually are now looking at re-wetting, so re-flooding, or allowing the water table to come back into that wetland. And you do this through a bunch of different things. You block the drains up. You can spray peat back again to allow the mosses to regenerate. You can reintroduce beavers who actually know how to do this work the best. They build dams. It's very efficient, and it kind of allows the landscape to flood again. And this is very critical work, because what we haven't understood as we dried out these lands is that all the peat in them, which store huge amounts of carbon, is off-gassing, and has been silently off-gassing. It's been like a kind of ticking carbon time bomb for decades. We've only just become aware of it. And the only way to stop that carbon from continuing to be released is to re-flood the land. But when you flood former wetlands, the agricultural practices of the last decades have to be replaced with other productivity in order to support the farmers who work there and live there in different ways. What we think is exciting about the wetland context is that there is a means of pairing landscape regeneration and material production that's not in conflict. In Brandenburg, vegetable growing, grazing sheep and cows, that's had to be replaced by something, and what they've replaced it with is farmed water buffalo. Water buffalo are a bit like cows, but they're much better at being wet. They have hooves and the physiognomy that's adapted to a wet landscape. And they're kind of critical to the ecosystem because they eat all the kind of young trees and shrubs, which would change the landscape from the wetland it is. They maintain it as open wetland, and they also have a kind of active role in fertilizing and maintaining the landscape. In material terms, we really looked then at what kind of reeds or paludiculture crops, they're called, like basically wet crops, could be farmed by the local farmers to their benefit in terms of the landscape and their economy, but also maybe for the use of the construction industry. And so we worked with these different manufacturers and farmers and conservationists to understand what material supply chains there already were, because actually people have been doing this work for decades. There's loads of really interesting research already. But then thinking about how they could scale, and how as architects we can start to have a role in growing that industry by specifying these materials. We found loads of really good stuff. I mean, there's like substitutes for plasterboard. There's even a foam insulation made of grass, which is better than spray foam. There's loads of really interesting alternatives, even to OSB, that are made with like reeds and grasses that come from wetlands. So then we looked, okay, like how practical is this? Sounds very nice. And we calculated the volume of materials you need, and how much you could sustainably harvest from a site without disrupting the biodiversity, like not cutting too much that affects the birds and amphibians, but just enough that allows the regeneration of the reed. And then we quantified how much material you need to build a new house and to retrofit an old house in the Brandenburg region. So a kind of classic typology from nearby. And we looked specifically at the site we were looking at, and keeping aside 10% for biodiversity, in a yearly cycle, you can grow 60 houses. It's quite straightforward. This is actually a very small site. Like, you can see the edge of it when you're standing in it. So when you think about how much wetland there is across Germany, then across the rest of Europe, it becomes very easy to imagine a material supply chain which could start to change the way we build. And teaching is sort of integral now to our practice. And we work with our students to make buildings and design buildings, but also work at the one-to-one, designing regenerative building systems. And this was a fragment designed by our students at the ETH last year now, made entirely with products from the wetland, bulrush, or tifa, or cattail, and reed. So all of the materials in this building system, probably apart from the screws, they come from the wetland. When we work with our students, we always work in groups to understand the materials we're looking at, how they perform, and how you can build with them. And with these skills, we then make the fragments together. This one is looking at the possibilities of eelgrass, which comes from coastal landscapes, as a kind of insulation material. We don't really focus in our teaching work on the program of the building, much more on the building systems and how they could be applied. Reed, so this kind of common wetland crop, and you see it at the edge of lakes and ponds, is kind of common practice in thatching. So we're all kind of familiar with it in roofing. But straw, which is really appropriate for thatching, is very rare now. We use fertilizers when we grow wheat, which we used to thatch with. And that really weakens the stem of the plant. It grows too fast and it becomes very brittle. So actually that's why when you're trying to, if you wanted to buy reed, for example, you would almost certainly have to import it from Turkey. And this is an exhibition that we did at the Building Centre in London called Homegrown, which was looking at the way that you could start thinking about thatched systems, not just as a roofing material, but as a cladding material. And also working with prefabrication, so kind of bundling into smaller panels, the thatching, to make it easier to add onto the cladding and to lift up. It was the first really iteration for us of a design we've been working on for a while of a vertical prefabricated thatch system. This thatch is actually a blend of wheat and rye, which is grown specifically for thatching. But whilst we used straw here, the next kind of iteration for us is going to be reed. And we've been thinking about different ways of like bundling the material so that it's a bit faster to put together. And we do this work with a thatcher. This is Mark Harrington, who's been helping us design the system. I guess the critical thing we found in starting to think about education space and also working on construction sites is that there isn't enough of the skill we need in the industry today to build the buildings like this. The materials we work with are not very well understood, and they're not taught. So if you go to a construction college today, you won't be taught about how to build with straw. And the construction industry has not been really good for the people who work in it. And how we respect labor and the body is tied with using fewer toxic materials. So we think it's about uncovering old skills when developing new ones. So we've been running courses through our platform now called Make, and we teach people to build with earth and straw and reed and hempcrete and lime. We do this through different construction sites across London. And we work with practitioners and workshop participants to think of a different model actually for construction training, one which is a bit more engaging and more participatory and reciprocal. Part of the work has been understanding the barriers to these skills and how we can work towards a more inclusive pool of skilled labourers who can work with and teach natural materials. So the programme is dedicated to applying ecological principles in the way we design. It bridges the disciplines of architecture and construction and agriculture and ecology. So we have ambitions now for the school to have a kind of permanent site. And we've been testing these possibilities through different projects, more recently at Growing Place and Pastoral Gardens in North London, which is supported by the REARC practice-based funding programme. I'm just going to talk very quickly about this project, but Pasture gardens is really typical of many of the small-scale urban farm sites which you get around London. And before becoming a food-growing site, it was kind of an unused and derelict piece of land. And farm sites like this have kind of been co-opted now productively by different growing collectives and enterprises. Emerging from these community farms is, broadly speaking, a kind of coordinated move for people to have more access to land. Ultimately, wherever we go in our work, we find ourselves coming back to the question of the land, like what's growing on it, who owns it, who makes those choices, who decides. The stewards of this land are a group of growers, including Black Roots and Wolves Lane. And this is a group photograph of the growers on site. And the project's aim has really been to develop a kind of building which serves them, which facilitates their work, which is a typology for other places and other farm sites like this. So we first worked with the community to look at the infrastructure they need on site, but also in the design of this kind of building typology, which would facilitate other sorts of learning and engagement on the land. As ultimately now we believe that in order to make meaningful change in the construction industry, we have to accept that there aren't any easy answers, and that all construction practices cause harm, and all require compromise. We think this requires the reimagining of how we use land at a local, regional, and national scale, but it also offers us a chance for economic and social renewal and a refiguring of how we live together on the land. So I'm going to stop. Thank you very much, and we can take some questions.
So thank you for the lecture. It was really it was beautiful. I'm impressed. How much work, also how really it's also so nicely presented on a photography and drawings, and yeah, I'm totally impressed. So thank you for your speech. I think we have now time for a few questions if you are interested, and okay, there is already, so go for it. So.
Hello. Thank you for the great lecture. I wanted to ask if, like in the current political landscape of Britain, when Labour won this huge landslide and they plan to build like this great amount of housing, do you think it's possible that like this kind of approach would be suitable for this mass scale development? Thank you.
It's a very good question. We talk about this a lot at the moment, because I guess the shift in the government structure in the UK has given us lots of hope, but also lots of calls for concern, I suppose, in different ways. No, broadly speaking, I don't think there's any reason why it couldn't be approached in this way, but I have very little optimism that it would be. I think we're increasingly trying to engage with policy and at least be part of the conversation around different ways of building, but I think the speed at which they aim to build will make it very difficult to intervene, and that is really disappointing. It's very short-sighted, but politics is short-sighted because they work within election cycles and not within like ecological cycles or human need. But we have quite a lot of homes in the UK that are empty. We have lots of communities which are rural, which are unoccupied. So different strategies to build rural economies might make those homes more desirable places to live. I guess we also feel like the scale of the new house building problem is nothing to the scale of the retrofit problem we have in the UK. I mean, 1.5 million extra homes would be nice. Maybe. I'm not sure. But the 28 million homes we have which need retrofitting are still cold and still damp and still mouldy, and aren't equipped for a decarbonised energy grid. Yeah, it's a good question. We're trying to get involved, but I think it can be very difficult.
Thank you for the lecture. So do you think the policy and the policy making is the biggest obstacle that you sort of need to overcome in terms of implementing this on a mass scale level, which is obviously necessary?
No, I don't think it is the mass obstacle. It really depends how much of a Puritan you are about what sustainable building. There's lots of materials which exist, which are kind of certified within the system we operate in, which you could use at scale. In that case, it's not policy, but it is these other things. So actually funding models. We don't really think about funding, but funding models are tied to warranties in the UK, and often I think in lots of places, and insurances. So when if you get government funding on large-scale housing projects, they demand a certain length of warranties, and some of these materials don't meet those requirements. Is that policy or is that money? It's kind of like the kind of background mechanisms of how money is controlled and leveraged are also a barrier. And then there's also this like cultural thing, which no matter what we do to prove the kind of performance of these materials and their kind of efficacy to make healthy homes and beautiful places to live, people are still worried, they're still concerned. There's like residual cultural resistance. So there's like so many different fronts. I think, yeah, I wish there was just the one. It would be so much easier.
Yep, I know. Yeah, thank you. So, do you think that actually trying to attain net zero standards is actually a limiting scope of what sustainability is for you in your practice, right?
I think it can be limiting. I think the assumption that any one metric is a good way of measuring sustainability is a problem. I think even if you approach your building through the lens of carbon, you will disregard a whole host of things which are important for us to consider, like the ecological impact of those materials, the biodiversity impact, the social impact. Sometimes the most lowest carbon thing you can do is ship it from across the world. Honestly, you do the math. Shipping globally through the sea doesn't use that much carbon. The container ships are enormous. They're going quite a long way anyway. But that doesn't necessarily mean it's the right answer to the problem. It really depends on your parameters and what your priorities are. And net zero it is a bit narrow in its focus. It's like passive house, it's very narrow in its focus. But people love an easy answer to the problem. And still, I think if everyone galvanized behind the idea of net zero, it would be better than not, because people aren't even moving towards it in practical ways. So I feel with net zero, I feel a bit like I feel about mass timber. I think it's fine that there's a mass timber lobby somewhere advocating the use of more timber in tall buildings, because they probably won't get very far anyway because of the cultural resistance. So it's good that they're making inroads. But broadly speaking, if we all did it, it would be very bad for woodlands across the globe. It's kind of like we sort of need a bunch of different movements towards different ends. Yeah.
Thank you very much.
Thank
you. Thank you. I wanted to ask, I would say that your approach is, don't take you wrong, but like learning from past, to take the step back. Mm-hmm. But what do you think about the opposite, like looking in the future and using the things like, I don't know, bioconcrete and this super-end, high-end, high-tech materials? So, yeah, that's the question.
So we do engage with like biomaterials, but I think a lot of it is avoidance. It's very difficult to argue that we should carry on. I think it's very difficult to make the case we should carry on working with concrete, but that case is supported by eco-concrete and by the movement to slightly reduce the emissions of concrete at scale. I think if we take infrastructure out of this, because it's very, I can't intervene in roads, I just don't understand civil infrastructure. I'm not going to be building sewers. I don't even know how much concrete is used in them, probably quite a lot. But in buildings, there are alternatives. I think it's a marketing thing as well. I don't know if, like, since when did concrete become the future? Like, how did modernism get to claim this, that this one material was the thing we associate with futurism and all these other things are the past? That's daft. The world is made of a whole host of different things. But I do think there is an amount of engagement with biomaterials which is avoidance. It's about maintaining the status quo, keeping the concrete industry going, keeping the steel industry going, keeping the plastics industry moving. There's not enough. It's not enough systems change to meet the crisis that we have. It's part of it. It's part of the problem. And maybe it's marketing. Maybe we need to talk about straw as the future. And I think that part of that is our work, is to make these materials like more sexy and more contemporary and show how they can make high-end design and that they could be the future too. But also, that's not my fight. It can be someone else's fight, making concrete zero carbon.
Hello, thank you for the lecture. It was very inspiring. I would like to ask you, usual criticism about ecological materials is the lifespan. So could you please talk a bit about the lifespan of ecological materials and what is how long can materials take?
Thank you. I think that's a really good question. I guess my answer would be like, what are those buildings in Prague made of? They look old. Are they made of concrete? They've probably been around hundreds of years. I walked underneath the bridge tower today. It was made of stone, and there was a thing on it that said it was built in the 1300s or something. How many concrete buildings have been around 700 years? I mean, it really depends which material you ask about, and it's like, how long is a piece of string? But timber buildings have stood for hundreds and thousands of years and are still standing in some places. Straw has been used for thousands of years. Actually, using straw in buildings kind of only regenerated as a process in about the 70s in North America, so we don't have that long in terms of examples. But there is a building in France made of straw and timber which was built 100 years ago. It's called Maison Fouillette. It's a contemporary building system. It's doing just fine. I think that really the question is about how we care for these buildings and the assumption that non-bio-based materials are really long-lasting. Because concrete that was built in most of the 20th century with reinforcement is all going to blow out, and all those buildings are going to fall down or need massive amounts of repair. But there is, I think, a resistance to this idea of care and this culture of repair being part of the life of being in a building. And really, when you work with a client of any substantial size, their aims are buildings that don't need maintenance, because maintenance costs money, and maintenance contracts are a pain. I think we do kind of have to rewrite our understanding of what it is to be a steward. There's a very interesting organization in the UK called Dark Matter Labs, and Indy Johar, who's one of the directors, was speaking at an event I was at recently, talking about really how we reframe in the future kind of governance models for how you build. And one of the key things in the future is thinking about who owns those materials and who is responsible for them. Because right now, when you design something, there's an idea that at its end of life, somebody will look after it. But really, the work is establishing now who's responsible for that kind of care and renewal. Yeah, I'm going to go figure out what Prague is made of, and then I'll come back.
So if there are no other questions, I will thank you again for your talk. And yeah, we will see us next week on another lecture by Martin Gielen from the Rotor from Brussels. And yeah, I will be happy if you will also join us next week. So thank you for coming, and thank you for the lecture.